So next we'll be looking at the sequence diagram. The sequence diagram is a type of UML, unified modeling language diagram used to model the interaction between system components over time. It shows how object or participants in a system communicate with one another. So this is a sequence diagram for login with biometrics. This is a sequence diagram of login with passcode. This is the sequence diagram to create node. This is for delete node. This is to restore the nodes. And this is for the editing the node. This is to perform offline backup. This is to share node via QR code. And this sequence diagram is to trigger emergency wipe. This sequence diagram of encrypt node. And this is for decrypt node. Next, we are going to look at the activity diagram. An activity diagram is a type of behavior diagram used in UML to describe the dynamic aspects of the system. So this is the flow of the system where launches add prop biometric authentication when the biometric is available or no, and no, it redirect to passphrase login, and user scans the fingerprint and verify biometric data and authenticity successful, the grant success. If it's not, it redirect to the passphrase login. So this is for the login using passphrase, where displays the passphrase login screen, enter the email and passphrase, validate credentials, same as the login as biometric, but this uses the passphrase. This is the activity diagram to create the node, where user opens create node screen and user enters the node content. User clicks save and encrypt node using AES256. Store encrypted node in local storage and save successful. This is to delete the node, and this is to restore the node. This is the activity diagram to edit node. This is the activity diagram to perform offline backup. So there's a backup section, user opens the backup section, prompt user to confirm the backup, user confirm, and then there will be a biometric confirmation also. So prompt biometric authentication. After authentication is successful, if not successful, fetch and reload, package nodes for backup, save backup. So if the authentication is successful, same, the backup will be done. If the authentication is failed, the backup will be failed. Next, share nodes via QR code. So user selects the node to share, and then biometric authentication again will happen after the successfully authentication is successful. Then the nodes will create a QR code, which will be encrypted using AES256, and then that node can be shared to anyone. And the other side, the user should be able to decrypt it to look at the nodes. This is an activity diagram for trigger emergency wipe. So user attempts login and validate credential, and yes, the access is granted, and if no, an error message is displayed. And after the threshold is met, the threshold will be set by the user in settings, and the threshold is met, there will be an auto wipe in the system where the nodes will be deleted automatically. This is the activity diagram for encrypting the node, and this is to decrypt the node. So this is a packet diagram. So this is a detailed description of the packet diagram where we have 5 subsystems, as you can see here. First one is authentication, which has it's basically built on a model view controller based subsystem. So in the model we have a login attempt page, and the view we have a biometric prompt and fast phrase page. And the controller we have a login controller, and the subsystem of authentication we can see the relationship between it is like this, where the login controller is connected to login attempt and also the user. Next, the subsystem is the node management, where in node management, the model is node storage, and node decryptor, and the view would be node editor, and the controller will be node controller. So here the node storage, node encryptor, node decryptor, and node controller is connected to the node, where the node contains node ID, node user ID, title, and also content encrypted. And the node controller contains create node, edit node, and also delete node. This is a subsystem of the security, where the model contains emergency wipe, the view contains wipe prompt, auto lock screen, the controller contains auto lock controller, where the emergency wipe is contains trigger wipe, user ID string, login attempt tracker contains increment failure, check limit. So the check limit is where the threshold is being set. And next, the auto lock controller, which is the main controller, has start lock mechanism and trigger wipe limit reach, where it triggers the wipe when the threshold is met. This is a backup and restore, and the model contains backup manager, restore manager, and offline backup. The view contains backup screen and restore screen, and the controller contains backup, restore controller. So here we can see the backup is being connected to backup manager and restore manager, because these two managers will be responsible for the backup from an external storage or an internal storage. Database design. So first we're going to see the entity relationship diagram, ERD. So this is the ERD where it has 5 tables: user, node, login, attempt, backup, and also QR share. So, and the entity and description, the entity name would be user, where store user account information including email, passphrase, biometric setting, and login rules. Next, node represent individual encrypted nodes created and owned by user. Login attempt records each login attempt including timestamp, authentication method, and result. Store metadata about encrypted offline backup created by user, including file path and time. Track nodes shared via QR code, including recipient code, time of share, and decrease state QR code. So this is the user entity for user. So the attributes will be user ID, email, passphrase, biometric enabled, and max attempts. This is the login attempt entity. This will be login attempt table and the data. Attempt ID, user ID, timestamp, status, and method. This is the node entity. It contains node ID, user ID, title, content encrypted, created at, and modified at. And this is the backup table where the file will be backup in local. So this is the most important part of the database where the nodes are backed up, and backup ID, user ID, file path, backup time, and also is encrypted and storage type. Next, this is the QR share entity, share ID, node ID, share to device, share time, and is descripted. So now we will look into the interface design. So first we have the page navigation design, where there's a table where how the pages will look step by step. When the user opens the app, you can select a node, or you have a setting page when you click on the setting button, and the setting will have a backup option and attempts set option, where you can set your attempts and also the backup. Next, when you select a node, there will be a biometric login page, and then you can, after success, you can view, edit, delete the node. And also with passcode, same. When the biometric fails, it will be directed to the passcode page, and there also you can view, edit, delete the node. And then when you retry until a set number of attempts until you reach a threshold, auto wipe will be activated. And there's also a page when when your nodes are automatically wiped. And there's also a page when you view, edit, delete node, you can also generate a QR code, and a QR code will be generated and shown in the page. So these are the interfaces. This is the main page of the app. When you enter, this is what it will look like. And when you generate QR code, this is the notes page. This is when when you log in with biometrics. And this is a setting page. As I said, you have number of attempts, restore setting, and also the fingerprint saving. So when you want to save your fingerprint, this is auto wipe page. When your notes are deleted automatically, this is how it has been shown. So in conclusion, the secure Notepad mobile application, a privacy-focused note-taking system with AES-256 encryption, biometric login, offline backup, and secure QR code-based note sharing is developed to end of this chapter. We present the project in chapter 1 by describing its background, problem statement, purpose, goals, and scope. In chapter 2, the technologies utilized in the suggested solution were reviewed. Current note-taking solutions were examined, and systems limitation were examined. The technical blueprint of the system and the technology tools and technology used and the selected methodology were all covered in chapter 3. And the entire system design, including use case modeling, class and sequence diagram, database schema, and interface layer, was presented in chapter 4. And that's the end of the report. So the achievement of the project objectives, the creation of secure Notepad, all project goals established during the planning phase has been effectively met. So, and by using built-in security logic, the second goal, integrating advanced security features with log emergency wipe, tamper detection was accomplished. So the suggestion for future improvement for this project would be there will be some of the areas that could be improved in future, enabling cross-device synchronization through peer-to-peer encryption without depending on any external servers, and enhancing the backup and restore process in another improvement. Backup are currently done by hand and saved locally, automating backups or scheduling the encrypted exports to safe external drives could make things more convenient for the users. And finally, a greater variety of designs, not only an Android API, Android-based note-taking app, we can also do it in iOS or a desktop, would be an improvement to be done in the Notepad app. So that's all from me. Thank you.